group 3, question 3. Is that Kui? Is that you guys? Who did I get that from? I got it from you, Kui, right?
Sure.
So our investigation question was, what are some of the structural features that might help us classify an acid as a strong acid or a weak acid? In our titration, we used acetic acid and nitric acid. So in our first titration, our sample of acetic acid was titrated with 0.1 molar of NaOH. I'm pretty sure we had 25 milliliters and we diluted with 25 milliliters of water. And our equivalence point was around 17 milliliters, the pH around 8.6, which is what we've shown with the line. After calculating the molarity, was 0.068.
So for our first titration, the half equivalence point is at 8.5 milliliters, and then the pH at that point is 4.3, which means half equivalence point pH equals pKa. From here we found the Ka value using our pKa. So using our Ka and the accepted Ka, we found a percent error is 178.3%, and that's very big, but because we're using such small numbers. And then our percent ionization is 2.71. And then, so we use NaOH. We use NaOH and nitric acid in our second titration. So a sample of NaOH was titrated by 0.05 molar of nitric acid. The equivalence point was around 94.5 milliliters, and the pH was around 7.4. And using our milliliters, we calculated the molarity to be 0.189. Yeah, just 1.1.
Okay, so to answer our question, based on the titration curves we had, we already knew that strong acids dissociate completely. So using that kind of feature, we already knew nitric acid was strong, so the H plus will get popped off over there, and so in that case it will donate more H plus, thus lowering the pH. And then for weaker acids, since they don't dissociate completely, the initial pH will be closer to 7, which we saw with acetic acid, which was initial pH was around 3. I forgot. And also when we hit equivalence point, is obviously going to be higher than 7 due to its conjugate base being stronger than the base's conjugate acid, thus creating OH minus ions.
So which bond are you talking about there?
For nitric, it'll be this one. For acetic acid, it'll be this one.
Okay, why not the other agents?
Well, it's part of the organic structure of the acetate.
So they're less polar bonds, right? These O and H bonds are very polar, so they dissociate better.
That's good. That's all.
Thank you. So their question was the structural features classifying acid as strong or weak. So that's important to recognize in terms of bonding structures, which is our next unit of study. So if this is foreign to you, it's fine. It's fine. All right, question. Our group 4. Is that you guys? Who sent me that? Gigi. I just saw hers. Okay. Excuse me. You guys can use the laser if you need it. It's present.
Okay, so our question was how do the structure and initial concentration of an acid and a base influence the pH of the resultant solution during a titration? And for our setup, we use 15 milliliters of 0.1 molar sodium hydroxide, into which the unknown hydrochloric acid was titrated, and then we had 15 milliliters of our unknown HCl, into which 0.1 molar ammonia was titrated.
If you look at the graph right here, this is our strong acid and strong base. And we started with the, it starts basic because we're titrating the HCl into the NaOH, and then it'll go down, and there's no buffer region, and there's no little curve at the top because they're both strong. And our equivalence point is about right here at 6.96, and our initial pH is about 13.17, which is indicative of a strong base.
So then for the particulate view, since it's strong and strong, all of the Cl like NA's or HCl and NaOH all dissociate or ionize completely, and then some of it forms the H2O because they would combine, and that is a neutral salt, so that's why it's a 7. The equivalence point is at 7 in the start data. And then to calculate.
Okay, so to calculate our molarity for our HCl concentration, we started off with our liters of our strong base, and then we went to our moles of our strong base and used mole ratio in the BCE, and then we divided that by the total liters of our strong base to get to our strong acid.
So that was.
So that was 56 mils of an area to the equivalence point.
Yeah.
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 Go back to your graph for me.
This one?
Yeah. Okay. Just start. Keep on. Thank you.
And this is our other graph, and you'll notice it starts at a lower pH because I guess we started with HCl and we're titrating the weak base into the HCl because the HCl was the unknown pH, so it was the analyte. And our equivalence point for this one, there's also no curl or no buffer region because it was the HCl that we were titrating. And the equivalence point was at about 6.3, and the initial pH is about 2.03 because we started with a strong acid.
So then at the equivalence point for this one, all of the NH3 originally, all the ammonia has become ammonium, and it takes on the NH4 plus, and this would be our salt, and we would use, because it's a basic salt, it forms, or its equivalence point is more highly, but we did ours backwards. I'm confused. It's lower. We look at this. Our equivalence point is lower because that's completely confused
Go
myself.
back to those previous diagrams. What salt did you make?
It'd be NH4 chloride.
Also known as ammonium
Chloride.
chloride. So this is
This that would be acid.
Okay. That's
Yeah.
what you're testing.
Yeah, and that's why it's lower.
So we actually couldn't determine KB because we had titrated our weak base into our strong acid. So, but if we had done it the other way around, we would have obtained the buffer region, which would then give us our half equivalence point, which would then we would use to get our PKB and then get KB.
So overall, because the strong is completely ionized, the changes for our steep portion is more sudden and drastic. It results in a lower starting and higher ending points. And then for the weak parts, it partially ionized. So the changes are not as steep. And for ours, we start with HCl, so that would start lower and doesn't go as high because in the end it doesn't ionize as much.
So you start with what?
We start with our acid for that.
So you added what on that? Sorry.
We add the weak base to the strong acid, and because it doesn't completely ionize, it can't go as high for the.
So the pH was what of the?
It ended with about 9.9.
And the other one had an extreme of.
It started at
It started at 13.
So that's kind of what relates to the question was the curvature and then the initial, and then this curve or this steep part is very, very vertical, and then the other one is it doesn't have as wide of a spread and it's not so vertical. Good job. Okay. Let's get maybe more. What's my next question? What's question 5? What is that question? Watch out for that trash can.
The structure of the acid and the titration.
Okay, hold on. So, here's what I'll ask. I don't have any, listen up. I don't have any time. We have May the, 7th is our deadline, right? And I can cut a day here and there in bonding. It just means I'm going to put some reading on you, and I'm not going to go in depth on something I want you to read. It's all qualitative, not so much quantitative. So, here's what I can do. I can do just multiple choice tomorrow. I can do free response on Thursday. So that means I need to present my last 3 groups tomorrow. I have 15 minutes left in class. All in favor, say aye.
Aye.
That's all. I can't do a full day push, but I can do a part day push. Okay, only because I lose most of the class for an ACT day and then registration and then another pre-ACT meeting. It's like buku crazy coming up here in March. So let's go ahead. If you have done the multiple choice I provided to you yesterday, you want to check that real fast? Okay, my last 3 groups will present like in 15 minutes tomorrow. Okay, and then I'll let you guys just sit and study. Yeah. For like a pure week. Yeah. Correct. Alright, so let's if you don't have that multiple choice done, you're just gonna have to write this answer on a substitute paper so you can do it yourself later, okay? Just gotta find it real fast. Hold on. That means basically you have a day to think about some questions you might have. You can sit up to school with me after I get talked to you about vaping. Quickly by the administration. Not me, just students. Alright, so the multiple choice I provided to you yesterday, I'll pull it up on my website. Yeah, I gave you a paper copy if you wanted it yesterday. I have like a couple of extra copies. Do we all know what I'm talking about? Okay, make sure we're on the same page. Oh, and while I got this lovely picture up here, I put some FRQs for you to practice, just for your own purposes, and you'll see the FRQs are here. It pulls up the entire exam, of course, but look for the acid-based one. Don't do like miscellaneous questions, and then you guys know how to find 2012 answer key FRQs. So there's some good titration ones on there that I think are very valuable, and some indicator ones that are very valuable. Okay, so like 2014 16 have 2 indicator ones. Okay, going back to this. Who's actually done like a portion of these multiple choice? Just give me a little hand raise. Great, okay, so let's discuss a couple as we go. Not that I required it by any means, I just was trying to see where we are. So it's called 33 multiple choice student copy if you're looking there. Here we go. Alright, so answer choices A through E go with 1 through 7, or 1 through 8 or whatever. So here we go. First off, classify 1. What do we have? Cassie, what is this? Salt. What kind of salt?
It's
Basic salt. Andrew, what do we have here? Salt. Basic or acidic? Basic. So your 2 basic salts, do they react? Salts don't react with salts generally, okay? So in this case, what do we have? Solution that is pH greater than 7, not a buffer. Good. 2, what do we have, JT? H3PO3?
That would be a strong.
It's not one of your strongs. Say again? Weak acid. Marcus, what do you have?
You have a salt.
You have a salt? What kind of salt? Don't talk to people. This is one person.
I'm going to say.
You have 2 seconds.
Basic.
It is a basic salt because that is not a strong acid as we just discussed here. Everybody, it's a combination of a weak acid and its conjugate. What do you have? A buffer. Is it acidic or basic buffer? Acidic because it was a weak acid. Nobody cares really about the strength of the other thing because it's just a conjugate. So answer C. Thank you. All right, 3. What do you have, Megan?
is that like an aniline?
It isn't as an amine, but just classify it. It's a weak base. We all should recognize NH2s as weak bases now, absolutely, with no option. What do we have here, CJ? CH3, NH3Cl. No, where's your H plus in the front? There's no H plus in the front. It's not an acid. Not a weak base either. That was a weak base. So this can't also be a weak base because they're very similar in structure. Keep going. No. Pick up. Somebody pick up here. It is a salt. How do you know it's a salt first off? First of all, you see the Cl. That's a really good indicator. Second, if that was a weak base and you say a very slight modification, that's CH3NH3 plus. So you have a cation and an anion. It is a salt. What kind of salt? It is an acidic salt, just for our purposes of knowing that. But it's like somebody else said, it's a weak base with a conjugate acid. You have a buffer, and it's the acidic or basic buffer. Basic. I feel like I'm a robot. I do this. I guide you through this, but I cannot guide you anymore. Okay. So like I am done teaching this content. Which was this answer? This is a basic buffer. So E. E is an elephant. Okay. All right. Decide. What do you have in 4? Weak, the base and strong acid. Oh my God, you got a reaction. What do you have at the end of this reaction? You're going to have a salt with its conjugate. If that's a weak base, it makes a strong conjugate acid, right? So it's got a conjugate acid. Who's in excess here? The weak base, right? 0.25 and 0.5. So you have weak base left over. You made its conjugate ion. You have a buffer. What kind of buffer? Basic buffer, which was answer choice E as an elephant again. So how do we prepare this buffer? Give me like the terminology we use. Partial neutralization. The other ones were direct addition because it was like weak thing plus the salt. This was partial neutralization. So you just have to make sure you're partially neutralizing. You're not at the equivalence point because that would be a totally different story. 5, what do you have? Weak acid and a strong base. Okay, hold up. So what's the quantity here? Who's in excess? Excess of strong base. Nobody cares about the salt at this point, right? We got excess strong base. What do you have? Just a basic pH, right? Not a buffer, right? This one will not be a buffer because you'll run out of the weak acid, leaving no weak acid, leaving no reason to have a buffer. 6. Acid-base reaction. Okay, who's in excess? HCl. Nobody cares about sodium hydroxide. You have acidic solution, not a buffer. Because there's first of all, there's no weak anything, and you're in excess of a strong. 6. What was the answer? Yeah. Because you still have strong acid left over, and it's so that can't compete, right? Yeah. Yeah, equimolar would be equivalence point, which means salt hydrolysis, which would be sodium chloride, which would be neutral pH. 7. Neutral salt, right? pH 7. A solution made of equimolar or equal volumes, KOH and nitric. Whoa, hold on. Where do you see weak acid? Strong acid, strong base. pH what, Christian? pH 7. It makes a neutral salt. It makes potassium nitrate, which doesn't appreciably react with water. Okay, those are really good multiple choice questions. I said the first page I thought were like quality because they make you think. Okay. 9. Hold on. If you haven't done it yet, you're going to have to mark these down for yourself. But yes, 9 is B. Why is that? Why is B the most acidic? Nitric acid is your strong. I don't think you had any other strong acids. Oh, you did right here, but E is strong acid and strong base, so it's going to come to a more neutral state. 10, closest to 7. I just answered that for you, right? E. 11. So pH greater than 7 is going to be the only one that has. Okay, so hold on, you guys said what? D could work. Oh, sorry, it says buffer. My bad. It's got to be a buffer because D is. Why is D not going to make a buffer? Right, you have nothing here to form the conjugate acid, so that ethylamine is going to be. It can't react with any part of that strong base, so it's not going to make its conjugate at all. It will not yield buffer. C makes a buffer because that's a direct addition of weak and its conjugate. 7 buffer with above or less than 7. A, so it's oxalic acid and its conjugate. Okay, keep going. We have a curve. Titration point of the solution is equal to, so basically pH is equal to pKa. What point? B, half equivalence point. This is the equivalence point of the titration. C, one of the points on the titration or on the graph. This is the point at which there's, or the most excess base has been added. The most excess base? E, right? Because, I mean, D is excess base, but the most excess base would be E. at this point the solution is a balanced buffer? First of all, which part of this is the buffer region? Which letters? You could say A to C, but it's really going to be like B-ish area. A is just the initial pH. It's not a buffer because there's no base has been added. There's been no partial neutralization. A is not a buffer. B is a buffer. C is equivalence point. Yet again, just a salt, nothing more. And then after that's just excess. So this is your buffer. So at the buffer, so this is a monoprotic acid. So at B, what is equivalent? Do not say pH and pK. What ions are equivalent? So HA equals A minus. So the weak acid is an equal concentration to its conjugate base. So before B, who you have more of? The acid. And then after B, but before you get to C, the conjugate base. Okay. So, but you guys see what I'm saying? And then at the equivalence point, you have equimolar of HA and NaOH. So at that point, you don't have any HA because it's reacted. So who's the only thing present at the C?
Salt.
So A minus, sodium ion, water. No, really, you don't have a lot of H plus and OH minus. They are an equal quantity, but not a whole lot. At C, at the equivalence point, you have A minus, which is your conjugate base, which is going to control the pH.
Answer to 16.
Oh, answer to 16 is B. Yeah. All right, laptop submarine. I'll scan this. I have 2 sets of work for this. I'll either scan it or I'll just type up the answer so you can check yourself too, okay? So, I haven't put the guidelines to what's on the test tomorrow, but I can do that today as well. I'll put it on my website. Good job, group so far. Group tomorrow, I'm expecting you to go furiously fast. Okay, furious. Yeah. No, you can turn your study evidence on Thursday. I don't need it yet. If you have more questions, text me or come see me after school. You just need to go back and look back at notes. You're going to be fine.